Okay, so we're gonna do this thing called the empirical formula. So what exactly does it do? Okay, so let's read through. In analyzing a compound to find its chemical formula, so we want to find out what's the compound's chemical formula. Okay, we actually determine the simplest, okay, I say again, we actually determine the simplest formula of the compound, and we term it as the empirical formula. Okay, so an empirical formula is actually the simplest formula of the compound. Okay, one example would be, okay, let me think of a good one. Okay, example, sugar is C6H12O6. This is sugar. Okay, this to be more precise, this is glucose. This is glucose. Okay, sorry. To be more precise, this is glucose. Actually, this is not the simplest form. If you want to look at the empirical formula is the lowest ratio amongst all. It's actually CH2O. This is the empirical formula for sugar. So you can see it's really going down to the lowest ratio. Okay, going down to the lowest ratio. There's another compound, okay, which is called ethene, which is called ethene. The formula is actually C2H4. Right, C2H4. The empirical formula will actually be CH2. This is the empirical formula. So you can see it's really what we meant by the simplest formula is actually broken down to the lowest ratio. Okay. So the empirical formula shows the different elements present and the simplest ratio of the atoms for the different elements present. So I gave you all these examples here just to let you have a sense of what exactly empirical formula is. Okay. Now, so how exactly do I go about calculating the empirical formula? So I'm going to show you an example here. Okay, typically an example, you have, like, for example, part A, they'll tell you that, a sample of glucose contains 36 carbon, 36 grams of carbon, 6 grams of hydrogen, 48 grams of oxygen. Find the empirical formula for glucose. We all know glucose is C6H12O6, of course, I already told you already. But if let's say the question comes out like this, you don't know it's C6H12O6. You go and do your analysis, you realize that there's 36 carbon, there's 6 grams of hydrogen, okay, and there's 48 grams of oxygen. So how to go about now calculating empirical formula of glucose? So first thing, you need to be able to do this table. Okay, so I need you all to remember the format of this table. So remember the table format, because the table format is going to help you to achieve the final answer. Okay, it's going to help you to reach to the final answer. Okay, so elements in the first row. So you can see carbon, hydrogen, oxygen. Second row is mass, units is gram. AR is the relative atomic mass. This is the number you're going to find in your periodic table. This is from periodic table. Okay, let me move the speaker a little bit. Then the third step is actually taking the mass divided by the relative atomic mass. And the last one is to find the ratio. So let's start. Okay, how to go about doing this? Let's look at the question. As mentioned, there's 36 grams of carbon. So I'm going to put 36 here. 6 grams of hydrogen, there's 6 over here. And 48 grams of oxygen, I'll put 48. So first row is really just to fill up whatever details that's given to you in the question. Next, I need to find the relative atomic mass of my, let me do something. Okay, I need to find the relative atomic mass of my carbon, hydrogen, and oxygen. So if you go to your periodic table, or if you look at a periodic table, you'll realize that for carbon, okay, those of you, if you, you have done enough of all the previous questions, you'll realize that, okay, actually it's not too difficult to find. Some of you even told me that you have sort of like semi-memorized the periodic table, which is good. It's not a bad thing, okay? So you have semi-memorized all the relative atomic mass. So good stuff. So we are gonna go into looking at the periodic table. This will be 12, this will be 1, this will be 16. Okay, in the form of your periodic table itself. So if I were to now, after I've done this step, what I'm going to do next is I'm going to take the mass divided by the AR. So in this step here, I'm going to take 36 divided by 12. My answer will be 3. 6 divided by 1. My answer will be 6. 48 divided by 16, your answer is going to be 3. But you can see here, 363 is not the lowest ratio. Now I need to find the mole ratio, right? What do you do to find the mole ratio? You divide by the smallest number from the previous row. So 3, 6, and 3, the smallest number is 3. So what I'm going to do here, I'm going to take this number 3 here. I'm going to divide by the smallest number amongst here is 3. So it's 1. In down here is 6. Divide by the smallest number, which is 3, is 3 over here. So it's 2. 3 divided by 3, I get 1. So the empirical formula for glucose now I know is C1H2O1. Obviously, I'm not going to put a 1 there. So this final answer will actually be CH2O. So this is the final answer. Like what I've mentioned here, CH2O. Okay, so take some time now to digest. Okay, take a look at this. I give you just maybe about 10 seconds to just relook at this example. Okay, 10 seconds to see how we went about doing this. Okay, so now let's continue with the next question. Okay, now next question, you go on to part B here. You realize that now is no longer mass, now it's percentage. Okay, is it still going to be the same way of doing? Okay, actually the answer is yes. So you look at this here, elements, mass, AR, mass divided by AR, and mole ratio. For part B, you realize percentage by mass, AR, percentage by mass divided by AR, mole ratio. So you realize instead of writing mass here, I write percentage by mass. So it is still sort of like a similar format. Okay, still sort of like a similar format. Okay, so let's start doing. Let me give you another example to show you here. Okay, sorry. Let me give you. Let me now do for you. Okay, this is 65.306. This is 32.653. This is 2.041. Okay, so I fill in the first row for you. Okay, based on whatever I've given. Now I want you to try out the last 2 rows. So I'm going to write for you the AR. So this 16, this 32, this is 1. I want you to just take maybe the next 3 minutes to just help me to fill up these 2 rows. Okay, just to make sure that you understand how to go about finding the third row and then the last row. Okay, so we take the next 2 to 3 minutes just to do this segment over here. Okay, so let's go. I'm going to pause the recording now. Okay, if round off to 3SF, what you realize is that your numbers may not be as nice, and sometimes it will affect your final calculation. So my suggestion would be, let's say if you really talk about the numbers are just too long and it's difficult to really keep track and you don't write so much, really all your working steps are all your working, okay, round off to 5SF. Only at your final answer, final row, you put to 3SF. Then of course, empirical formula, when it comes to empirical formula, you know that this one is no SF one. Okay, because your chemical formulas, I mean, you don't really see a carbon. Wait a minute. I mean, okay, can you imagine you write like that? You write O4S H2.00018375. I mean, you don't really see a formula like this. Am I correct? So therefore, okay, this is nonsense. That cannot. Okay, really, when it comes to the final formula, every single thing is an integer. So empirical formula, no SF, it is only whole number. Okay, it's only whole numbers. So just take note. Any questions so far? Okay, thumbs up if all is good. I'll go on to the next slide. But if you have any question, can ask anything. All okay? Thumbs up. Okay, give me a thumbs up if all is okay. Then I'll go on. Turning on camera, your reaction button, thumbs up. Okay, good. Okay, so I know using if you're using iPad, you realize it's a bit difficult because you switch between the screens. So yeah, okay, paise. Okay, I'll try to not let you switch screen. Okay, let's go next slide. Okay, slide 9. Okay, now the molecular, okay, so now we're gonna be, other than empirical formula, okay, we're gonna do this thing. You see, empirical formula itself is the simplest ratio. It really doesn't tell you what the compound itself is. Okay, I say again, the empirical formula doesn't really tell you what that compound exactly is. Okay, but what we're gonna do, we're gonna learn how to derive it. So the molecular formula of a substance can be derived from its empirical formula if the ratio n is known. Okay, the ratio n is sort of like tells you how many times of the empirical formula gives you the molecular formula. So if I look at glucose, right? Okay, glucose, I know the empirical formula is CH2O. The ratio, which is n, I know is 6. So you realize if I multiply the whole thing by 6, that's how I do it. I get C6H12O6. This is the molecular formula, okay, of glucose. Hydrogen peroxide, the empirical formula is HO. I know the ratio is 2. So realize HO, I'm going to multiply by 2, I get H2O2. Butene, empirical formula is CH2. The ratio N is 4. So I'll put a 4 at the bottom here. So it's C4H8. So I want you to just take note at how the N is used. Where did I insert the N? Okay, the working itself is important because it's very funny to write this. Can you imagine you write CH2 4 times equals to C4H8. This is not how you go about doing the working. This is the wrong working. Okay, so please don't go about writing it like that. Okay, see how I go about doing the working over here. So the ratio n can be determined. Okay, now the thing is, yeah, good, I know the ratio, I can find the molecular formula, but how can I get that ratio? How can I get that n? So it can be determined if the empirical formula and the relative formula, if the empirical formula and the relative molecular mass is known, or if it's known. Or if the empirical formula mass and the relative molecular mass is known. So why? Because if I take the relative molecular mass divided by the relative mass from the empirical formula, I can actually find the n. So let me give you an example. Okay, let me give you an example. So part A, compound X has empirical formula of P2O3. Its relative molecular mass is 220. So this is the MR, relative molecular mass. Now, I want to find the ratio. So let's just put this whole thing in together. So I know the relative molecular mass, so I got this guy here, but I don't have the relative mass for the empirical formula. So let's find. What is the, so this is the relative mass of the molecule. Okay, let's find the MR of the empirical formula. So how to find? This is equals to 2P plus 3O. This is the empirical formula, right? That we've got here. So phosphorus, okay, if I look at my periodic table, so let me now go show you the periodic table. So phosphorus is over here. The relative atomic mass is 31. O is 16. So it's 2 times 31 plus 3 times 16. So this is 62 plus 48. You will get 110. So this is the empirical formula of your P2O3. Let's find N. N will be the relative molecular mass of the molecule. So MR of molecule divided by the empirical MR of the empirical formula. So I know it's 220 over 110. So answer is 2. Then the last step, okay, now to find the molecular formula. Therefore, the molecular formula is actually equals to P2O3 2. Okay, so you can see how I go about doing. This is my N. So this guy here, sorry, let me highlight here. This is actually my N. So my formula actually will be P4O6. This is the molecular formula. This is the ratio. Okay, statements are important because it helps you to follow through that train of thought. So I've worked out once. Now I want you to try part B. Okay, can you try part B? Just give yourself about maybe 2 to 3 minutes again. Try calculating part B. Make sure that you understand how to go about doing this question. Okay, so let's go. Okay, let's carry on here. Hopefully you have you're done with this, but let's give it a try. Okay, so they say the molecular compound Y has an empirical formula C5H8. Relative molecular mass is 68. So this is the MR of the molecule. Okay. Determine the molecular formula of compound Y. To know the molecular formula of Y, actually there's one step here I need to do, which is to find N first. I need to find the ratio. I don't have the ratio, I cannot find the molecular formula. Okay, so you realize the steps are exactly the same as above. So the first step, find the MR of the empirical formula. Okay, or you can think of it as the empirical formula mass. So this is gonna be 5 carbon plus 8 hydrogen. This will be 5 times 12 plus 8 times 1. So this is 60 plus 8. You're going to get 68. Then the next one is to find the ratio. So the ratio is to take the MR of molecule divided by the MR of empirical formula. I'm just going to write empirical formula, EF. Okay, you realize it's 68 over 68. Therefore, I get 1. Hence, the molecular formula. Okay, all these steps are important. Please, although I know that you say, sure, I know 68, 68, then the formula is like that, but do follow through it. C5H8, 1. Our answer is C5H8. It is of Y. Okay, so I need to follow through. Okay, follow through literally all the steps to get to the final answer. Okay, because each of the steps has its own working, and each of the working actually has its marks attached to it. Okay, this actually shows that you understand what's happening. Okay, so part B are done now. Okay, let's go on to part C. Okay, let's go on to part C. Okay, so anion Z has a double negative charge. Okay, so I add a layer now. I told you Z has a double negative charge. What does this mean? It means it's a Z 2 minus. So Z, whatever thing you're going to find, the overall charge is 2 minus. Its relative molecular mass is 224. Okay, this is the MR of Z. It has an empirical formula of S2O3. So this is the empirical formula. Okay, now I want you to find the chemical formula of the anion Z. So I add a little layer of difficulty here because now it's no longer just a molecule. I say that it's an ion. Okay, I say it's an ion. Can you now find the chemical formula of Z? Okay, it's the same step except that now it's an ion. That's the first thing. Second thing is that down here, once again, you realize I never tell you to find N, but that's something you need to do also. Okay, so take the next 2 to 3 minutes. Once again, go and try this out just to make sure that you have gotten it. Okay, so I'm going to give you all maybe about, I think you should be better now. So maybe 1.5 minutes. Okay, let's go. So you would have done the exact same steps. Okay, but let's just write down the working here. So I'm going to find the MR of the empirical formula. So this will be 2S plus 3O. So 2 times 32 plus 3 times 16. 64 plus 48. I'm going to get 112. Okay, 112 is the MR of the empirical formula. Next, I'm going to find N. N is actually 224 over 112. This will be 2. And the last one, I'm going to find the chemical formula of Z. Okay, this will be S2O3 multiplied by the ratio 2. The overall charge, as mentioned, is a double negative charge, so it's a 2 minus. So this thing, no other 2 minus outside, not inside. I say again, the 2 minus is outside, not inside. Okay, so once you've gotten once you've multiplied in, your final answer is S4O6 2 minus. Okay, so this will be the answer. Okay, for part C. Okay, so now the thing is this, what I've done so far is to split. Okay, I say again, is to split the question up. First, I teach you how to find empirical formula in the previous slide. Then I teach you how to calculate the molecular formula, okay, based on whatever relative mass that's given to you. In actual fact, in the question, both are actually merged together. Okay, both are actually merged together. So this is actually how a question would look. Okay, look at question 5 here. First, step A, determine the empirical formula of X. B, now determine the molecular formula of compound X. So it's actually the same as what you have done previously, except now we have merged it all into one question. Okay, we have merged it all into one question. So you can see question 5, question 6. Now, what I'm going to do is, I'm going to show you how to do question 5, although you may say, it's so easy. Okay, but let me just go through this together with you. So I need to, the question says 2 grams of carbon completely react with 33 grams of hydrogen. So I know compound X consists of 2 grams, 2.00 grams of carbon. And I know it's made out of 0.33 grams of hydrogen. Okay, the relative molecular mass is 28. Okay, relative molecular mass is 28. Now, this one here is mainly used in part B. This one here is mainly used in part A. Okay, so that's actually how you go about dissecting the question. Okay, so let's carry on. So let's start. First one, let's find the empirical formula. So before you start, draw the table. Okay, draw the table. I need you to draw a table with ruler and stuff. Right now, I'm not going to draw a ruler because on my screen, we have to draw a ruler. But in the actual exam and actual test, please make sure you have a ruler with you to just draw the form. So the first row is actually the element. This one is mass, not percentage mass. So I know my second row is mass. I know my third row is AR. My fourth row is the mass divided by AR. And my last row is the ratio. Now the mass here, take note, it should be in gram. Okay, so I'm going to draw my lines down like that. I know my second row will be carbon. The second column is hydrocarbon. My third column will be hydrogen. Okay, so this is my rough table over here. Oh, sorry, ugly lines up. Let me draw properly. A bit better. Okay, so let's fill in the steps. So this one here, I know is 2.00 gram. Sorry, this one's right gram. Gram will be written there. Now here's 0.33. AR for carbon is 12. AR for hydrogen is 1. Okay, so these are all the details you can get so far from the periodic table and from the question itself. This is where the calculation comes in. So mass divided by AR, I'm going to take 2 divided by 12. I'm going to get 0.16666. So let's do 5 SF. 1, 2, 3, 4, 5. So 5 SF should be here. So this is the 7. This one here, 0.33 divided by 1. So this is 0.33. Now, so which is the smaller number? Okay, which is the smallest number? Answer will be this one over here. So this is the smallest number. So to find the ratio, I'm going to take the both number divided by smallest number. So this actually be 0.16667 divided by 0.16667. This will be 1. This will be 0.33 divided by 0.16667. Okay, you realize that this one, this one when I divide is not so nice number. I usually get 1.9799. Yeah, even if I round to 3SF, you realize that this is 1.98 over here. Can I round up? Answer is, if it is very, very close to the whole number, yes, you can round up. So 1.9 is still all right. Okay, so you're going to make a judgment call here. In this case, when you follow the steps 1 and 1.98, you know that, this is a very clear-cut empirical formula. So please complete with this empirical formula of X is actually, this will be C1H2, so CH2. Okay. So this is the empirical formula for X. Okay, I know some of you, your iPad now in guardian mode sleeping already. So if you want, you can take pictures of this. Okay, no issues. Okay, so this will be the empirical formula of X, which is CH2. Now the last part, find the molecular formula of compound X. So I'm going to find the molecular formula now. So to find the molecular formula, first we need to find, the MR of the empirical formula first. So you realize it's a very systematic way of trying to get to the molecular formula. So I know it's CH2, so I got 1 carbon plus 2H. This will be equals to 1 times 12. So yeah, 1 times 12 plus 2 times 1. So this will be equals to 14. Okay, 14. Let's find the ratio N. And I must take the MR of X, which is 28, divided by the MR of the empirical formula, which is 14. My ratio is 2. Then the last step, molecular formula of X. This will be CH2 bracket 2. Then I'm going to get C2H4. This is my molecular formula of X. Okay, so you can see the whole ching-jang of steps here. Okay, do the table to find empirical formula. Once you got an empirical formula, you go about doing the MR of empirical formula, find the ratio, then find the molecular formula of X. Right, very systematic, very clear. So the last question here is really for you all to try it out. I just need to take note. An oxide of nitrogen contains 3.68% of nitrogen. You realize oxide of nitrogen contains. Then what happened to the rest of the percentage? This is the one where you need to find out how much oxygen there is in terms of percentage. Okay, so do the empirical formula to find the oxide of nitrogen. Then you can find the molecular formula of oxides of nitrogen. Okay. So question 6, I want you to go and try now. Okay, I'll give you about because this is a bit tedious, maybe I'll give you about 4 minutes. Okay, to go and try this out. Okay, so give 4 minutes. Okay, your time starts now. Okay, so let's carry on just to make sure that you all got the correct things. So first part, let's go through to draw the table again. So I got element. So I got nitrogen, I got oxygen. This time around, it's not mass, it's the percentage mass. So nitrogen, I know is 36.8. Oxygen will be the rest, will be 100 minus 36.8. So this will be 63.2. So I need the AR next. Nitrogen is 14, oxygen is 16. I'll need to take the percentage mass divided by the AR. Then the last one is to get the ratio. Okay, so percentage mass divided by AR, 36.8 over 14. This will be 2.6286. Okay, that's for nitrogen. For oxygen is 63.2 divided by 16. I'm gonna get, let me press 63.2 divided by 16. I'm gonna get 3.95. So you realize now the numbers are not so pretty, it's not so nice. Okay, so this is where, that's why you need the ratio. You need to take, ratio means to divide by the smallest number. In this case, this is a smaller number. So obviously anything divided by itself will be 1. So N will be 1. Oxygen will be 3.95 divided by 2.6286. You're gonna get 1.5027. Okay, I'm going to do 3SF, so 1.50. Now, if you look at this, once again, this is the point where I'm going to say that empirical formula, you know that it cannot be a ratio. It cannot be a decimal. So therefore, the empirical formula, okay, of the oxide of nitrogen. Those of you who wrote NO 1.5, nonsense. So what you do is you need to take the whole thing and times 2. So this will be 2, and this will be O3. Sorry, this is 2 and 3. Okay, sorry. So the empirical formula actually be N2O3. Okay, this is the empirical formula of the oxide of nitrogen. And step B, determine the molecular formula. So I think this one is where most of you are more familiar already because we've done it most recently. Okay, once you're able to get the empirical formula of N2O3, I'm going to now find the MR. Okay, MR of the empirical formula. This will be equivalent to 2n plus 3o. So I'm going to get 2 times 14. Oh no. 2 times 14 plus 3 times 16. So 28 plus 48. So I'm going to get 66. Okay. Am I going to get 60? Yeah, no, sorry, not 66, 76. Okay, 76 over here. Let me just double check out 28 plus 48. I'm scared. Okay, 76, yes. Next, I'm going to find the ratio n. So I'm going to take the relative molecular mass 152 of the compound divided by the empirical mass 76. You realize when you do this, n is 2. Lastly, I'm going to find the molecular formula of the oxide of nitrogen. This will be to take the empirical formula, which is N2O3, multiplied by the ratio, which is 2. You're going to get an N4O6. Okay, so this is how you go about doing this. And I think you realize that, okay, once you get a hang of this whole method, it is not too difficult to actually do it. And of course, some of you will be starting to ask, sure, if this one comes out in exam, like, or test, how many marks would this be? This will be at least worth about 3 to 4 marks. Okay, so it's actually quite a good 3 to 4 marks to get because it's not really too demanding once you get a certain flow of the steps. Okay, once you get a certain flow of steps. So this will mark the end of the mass calculation already. Okay, this will mark the end of the mass calculation. So you realize, based on whatever we have gone through, okay, so I'm going to go back to that slide, I think slide 8. Okay, no, not slide 8, slide 7. Okay, at the bottom here, we covered these 4 points. Actually, the 5th point that we covered today is the whole idea of the empirical formula. The mass. Okay, so empirical formula, how to find the ratio. Oh no, sorry. Ratio, which is n, and then how to, from the empirical formula, get to the molecular formula. So this was what we went through for today. Okay, so quite a bit in terms of the math calculation, but it's really to get you through the various steps. Okay, so this is the end until worksheet 10 already. I'm going to go on to worksheet 11 now. Okay, so we're just going to do on something a little bit not too tough now. It's a bit simpler. Once again, it's another calculation, but it's not as tedious as compared to the previous one. Okay, so what we're going to do, we're going to state what Avogadro's law is for this worksheet. We're going to learn what is this idea of a molar volume of a gas. Then we're going to learn how to calculate the volume of a substance when given a number of moles. So this is the interconversion I'm going to talk about. So this is another one of the conversion you need to know. Conversion. Okay, then finally you learn how to interconvert between all the various things again. Okay, so let's start by looking at the question. Okay, Avogadro's law states that equal volumes of all gases, equal volumes of all gases under the same condition of temperature and pressure contain the same number of particles. So that means the same volume will occupy the same volume will contain the same number of particles. And hence, the real conclusion is here. Okay, the real conclusion is here, which is 1 mole of any gas will occupy the same volume. So it's interestingly, what they're trying to say is 1 mole of gas will have the equal, will have 1 mole of any gas, to be more precise, 1 mole of any gas will give you the same volume. Okay, for those who want a reinterpretation of it. Okay, 1 mole of any gas will give you the same volume. So the question is, what is this volume? 1 mole of a gas, what's the volume that it will occupy? Okay, so the volume that occupy is known as the molar volume. What is the molar volume? It's actually 24 dm3. Okay, so at room temperature and pressure, what is the volume occupied by 1 mole of gas? It's actually 24 dm3. What exactly is 24 dm3? This is the same as 24,000 cm3. Okay, so 24 dm3 is cubic decimeter. Okay, decimeter, cubic decimeter. It is actually equivalent to the same as 24,000 cm cube. Yeah, most of the time you are more familiar with cm cube, but in chem, you will see whenever we talk about volume of gas, we tend to use dm cube, okay, instead of cm cube. So just take note of that. Okay, so part B, okay, it's really proportional. Calculate the volume of gas occupied by 0.5 mole of carbon dioxide gas. So I know that 1 mole of CO2 will occupy 24 dm cube. Okay, this is what I know. 1 mole of any gas, if it's CO2, then CO2 it will occupy 24 dm cube. So question is, how about the volume? How about the volume occupied by 0.5 mole of carbon dioxide gas? Hence, 0.5 mole of CO2 will occupy 24 times 0.5 over 1. Okay, 0.51 because 20. Yeah. Okay, it should be like that. 24 divided by 1 times 0.5. I will get 12 dm cube. Okay, so this is how you go about, really is by simple proportion. So I want you to try part C just to make sure that you get a hang of how this proportion works. So 1 mole occupies 24 dm cube. Then if I got 0.5 mole, it's literally just half of it. Okay, but I want you to do it in terms of this working like this. Sorry, I shouldn't. I want you to do it in terms of this working like that. Okay, because not every single proportion is like 0.5. It could be uglier. Okay, it could look uglier. Okay, it could maybe like 0.002567 kind of thing. So that's why I want you to try to do this kind of working. Can? So I want to try now part C. Okay, give you all 1 minute. Just go and try it out. Okay, let's go. Let's carry on. So how to go about doing this? Okay, so I want to find volume of gas, volume of argon gas. Okay, volume of gas, but this kind I want is for 0.02 mole, right? Okay, so this will be taking 24 divided by 1 multiplied by 0.02 because I know 1 mole of argon gas is going to occupy 24 dm cube as well. Okay, so you realize after a while, don't need to write the 1 over there. Yeah, don't need. Okay, so 24 times 0.02, what you're going to get is 0.48 dm cube. Those of you who thinking, if the question asks me in cm cube, right? Because they say in cm cube, what do I need to do? Actually, this will be 480 cm cube. How you get from here to here, you multiply by 1000. Okay. So based on part B and part C, you realize, now I need to know one more conversion, which is mole of gas. Okay. How to convert to volume of gas. So mole to volume, you multiply by 24 dm cube. Obviously, to reverse is to divide by 24 dm cube. Okay. So for those who are more interested in using the triangle, okay, those who are more interested in using the triangle, so this volume of gas here, this is mole of gas. Take note, this 24 dm cube can only be used for gas. If it's not gas, you cannot go and use this 24 dm cube. Okay, so this is how you go about doing part B and part C. Now, let's go on to something slightly more difficult. Okay, now, I want to find the volume of gas occupied by 64 grams of oxygen. Wow, you only teach me mole. You haven't teach me how to convert from mass into volume. So this is the part where some of you are like, how to go about doing this? I need to take note. If you go and look through exactly based on whatever we've gone through so far, as long as I know the mole of a substance, I can convert it to every single other things. Okay, so take note, I want to say this. If you can find the mole, you can convert to other quantities. Okay, what are my quantities? Could be mass, could be volume, could be number of particles. Okay, so if you can find the mole, you convert to other quantities. So what I'm given so far is 64 grams of oxygen gas. To find the volume of gas, I know the first thing I need to do is to find the mole of O2. If I can find the mole of O2, I can readily convert to the volume of gas, isn't it? So the question is, Cher, you write this arrow here for what? Actually, by drawing this arrow is let you see how the thinking goes. If I can find the mole, I can find the volume. So how to get from the mass, this is mass, so I want to annotate this is actually mass of the gas. How to get from mass to mole? You first must divide by the MR. Okay, I can readily say it out, but for those of you, if you need a paper with all the interconversions present there, go ahead, do up that paper. Okay, because that will be very useful for you, especially at the start when you're doing all these interconversions. Once you're used to it already, actually you'll be fine now. So I know from mass to mole, I divide by MR. From mole to volume of gas, I need to multiply by 24 dm3. So this is the step I'm going to do. Okay, first always convert to mole. Then after that, I'll convert to other thing else. So that's fine. Okay, I need to take the 64 gram divided by MR, right? But first I need to find MR. So that's fine. MR of oxygen. MR of O2, see O2, O2. So this 2 oxygen. So this 2 times 16, this will be 32. Once I found the MR of oxygen, okay, next I need to find the mole of O2. So this will be 64 divided by 32. I get 2 more. And lastly, I want to find the volume of O2. I'm going to take 2 moles multiplied by 24 dm3. So I'll get 48 dm3. So realize, voila, easy peasy. It is easy peasy because I already came up with the frame. I know what are the steps I need to do. I know how these are the steps I need to take in order to get to the final answer. So realize it's not as easy as just a snap of a finger. Okay, you need to be familiar with the approach of how to get to the final answer. Okay, so let's go next question, question 3. Okay, now maybe instead of doing question 3, let me I want to redo this question. Okay, I want to change this. Okay, cancel this. Cancel this out. Cancel this whole thing here. I want to cancel all this. I just want you to start with this 52 dm3 of nitrogen gas. I want you to find as many other quantities, okay, of N2. Okay, I want you to find as many other quantities of N2 as possible. Okay, so based on this 52 dm3, what other thing can you get? Okay, so I want you to take this maybe the next 4 minutes, okay, based on whatever I picked up. From this 52 dm3, what other thing can I get from it? Okay, do your calculations and work it out. Okay, I'm drawing all these arrows, but actually may not have that many quantities. So go and try, take the next maybe about 3 minutes, okay, to go and find out what are the various other quantities you can find. So let's go, let's carry on. We are struggling thinking what other quantities of N2, right? What do I mean by that? Okay, I have quite a number of you who are asking me. So maybe just to give you an example, I'll use this as an example. Okay, so what I have so far is 52 dm3 of nitrogen gas. So this is like the volume of N2. Okay, so I have the volume of N2. Now, but the question is, from the volume of N2, what are the other things I can get? So what I know is, if I got volume of N2, I can find the mole. Because why? I know that the volume of the gas, I can convert it to mole of the gas. Okay, and how to do this is to divide by 24 dm3. So the first thing I'm going to do, okay, since I know this, I'm going to find the mole of N2. This will be 52 dm3 divided by 24. So I know that this is 2.17 mole. Okay, so this is to 3SF. So this is the first quantity that I got. Okay, the mole of N2, which is 2.17. So this is one of the possible quantities. Okay, this is one of the possible quantities. Now, what are the other quantities that I can get? So other than the mole, okay, you know that you can actually, from mole, you can, so the mole of N2, I can actually go and find the molecules of N2. From the mole of N2, I can also find the mass of N2. Okay, so let's go and try. Okay, now let's try the mass of N2 first. So let's find the mass of N2. So I'm going to take the mole, which is 2.17. I'm going to multiply by the MR, because from the mole to the mass, I need to multiply by MR. So what's the MR of N2? So I'm going to shorten the whole thing. I'm going to now calculate the MR within the thing itself. So N2 consists of actually 2 multiplied by 14, 2 times of nitrogen. Okay, so 2.17 multiplied by 28, you're going to get 60.8 grams. So the mass of N2 is 60.8 grams. So this is the another quantity that I can find. Okay, this once again to 3SF. Third one that I can find, as mentioned, is the number of molecules of N2. So mole to molecules, what I need to do is multiply by 6 times 10 power 23. So this will be, take the mole. So I'm going to find the molecules of N2. This will be 2.17 multiplied by 6 times 10 power 23. Okay, 2.17 times 6 to the power of 23. I will get 1.302. Okay, 1.30 because it's 3SF times 10 to the power of 24 molecules. Okay. Actually, got one more. From the molecules of N2, I can actually find the atoms of N. Because why? N2 convert to N. So you need to know that if I got one N2, this means that I got 2 nitrogen atoms. So one N2 molecule actually means that I got 2 nitrogen atoms. So if I got 1.3 times 24 molecules, okay, so this is the third quantity that I have already. I'm going to calculate now my final and last quantity, which I am able to do so, which is atom of N. This will be 1.3 times 10 power 24 multiplied by 2. I get 1.30. This is 2.60 times 10 power 24 atoms of N. So this is what I mean by, okay, find as many quantities as you can. Literally try to find all the things you've done before. You learn how to calculate mole, learn how to calculate molecules, atoms, mass. So literally try to apply all the various formulas you have picked up before. Okay, so this is what I meant by that. Now I want you to try. I'm going to give you another one. Okay, let's say I give you let me try something. Okay. If I say that there's 110 grams of CO2, 110 grams of CO2, I want you to find for me as many other quantities of CO2 that you can based on what I've given you. Okay, so we're going to try this out now in the space over here. Okay, all the space over here, we're going to try it out now. Okay, from 110 grams of CO2, what else can I find? Okay, so we'll end off the lesson with this. So let's go and try now. Okay, we're going to try now before I go through it. So let's go. I'll give you about 3 minutes. Carry on. So this, let's end off with this. Okay, so we are given 110 grams of CO2. This is actually the mass of CO2. Now, when given the mass of CO2, what can you find? Okay, you know that the mass of CO2, I can actually convert to find the mole of CO2. Okay, to do this, you need to divide by the MR. So let's start by finding the mole. Okay, so the first thing I'm going to do is to find the mole of CO2. Okay, so the mole of CO2 will be 110 divided by the MR of CO2, which will actually be 1 times 12 plus 2 times 16, which will be 44. So 110 divided by 44, you're going to get 2.5 mole. So this is the first quantity that I got, the mole of CO2. Maybe the next one I can try from the mole of CO2, let's find the volume of CO2, okay? Because volume is the last thing we covered so far, right? So volume of CO2, to find the volume of gas, here I will actually need to take the number of moles, multiply by, so mole to volume of gas, I need to multiply by 24 dm cube. So multiply by 24. So 2.5 multiplied by 24, you actually get 60 dm cube. Next one I can get is from the mole, I can also find the number of molecules. So in this case here, the third one, let's find the number of CO2 molecules. This will be equivalent to 2.5 multiplied by 6 times 10 to the power 23. Okay, 2.5 times, 2.5 times 6 to the power 23. You're going to get 1.5 times 10 to the power 24 molecules. Okay, so these are all that you can calculate. I mean, some of you say, how about atoms? Number of atoms. So question is, CO2 is made out of 3 atoms, right? So 1 CO2 is actually made out of 3 atoms. So maybe the fourth one I can find is the total number of atoms. Because I can't say total number of C atoms, right, or O atoms, I can maybe find the total number of atoms. So this will actually be 1.5 times 23 multiplied by 3 atoms. Okay, because one molecule give me 3 atoms, right? Okay, you got 1 C and 2 O. So I get 4.5. Sorry, this is 24. I see. Let me do this. So this 4.5 times 10 to the power 24. Okay, atoms. Okay, so I hope you are able to interconvert between all of them already. And the homework I want to leave you with for today, okay, let's go all the way down to end of worksheet 5. Okay, it's really to find if I have 9 times 10 to the power 24 molecules of hydrogen chloride. Okay, hydrogen chloride, not hydrogen chloride, ammonia gas. Okay, ammonia gas, NH3. Okay, what are the quantities? That you can find? Okay, so this will be the question. Now I'm going to do is I'm going to scroll back up again. Okay, just let you all copy this one here. Okay, later on I'll go back up. But maybe copy this question down first as a checkout. So write this down. I'll give you about 1 minute to write down. Then I'll scroll back up to the answer, just of the previous answer, just to let your copy finish. Because I realize some of you haven't copy finished yet. Okay, so 9 times 10 to the 24 molecules of NH3 gas. What are the other quantities you can find? Okay, so this will be like your checkout question that you all can do on your own, just to make sure you consolidate all the interconversions. Can I scroll up? I give you maybe about another 20 more seconds to just copy this. 20 more seconds. Maybe I scroll up. Okay, let me scroll back up. Okay, once you copy down all this, actually, it will be the end for today's lesson already. We will continue the rest of the segment in next week. Okay, so that's all for today. So just make sure that you all complete all the work that you need to do. Okay, so that's all from me.